Hello students, today we will see how to calculate the eigenvalues and eigenvectors for the given matrix. Let's take one example. If A is given as 3 minus 5 minus 2 minus 4 and they ask you to find out numerically the largest eigenvalue of matrix A by the power method. Here I just missed the word eigen. So consider largest eigenvalue of matrix A by the power method. Consider initial approximation x0 they have given as 1 and 1. So let's start. The solution for iteration 1 will be A x0. Putting the value of A and x0. What is A? A they have given as 3 minus 5 minus 2 4 and x0 they have given as 1 1. So 3 minus 5 minus 2 4 1 1. So 3 into 1 minus 5 into 1. So 3 into 1 minus 5 into 1 minus 2 into 1 plus 4 into 1 minus 2 into 1 plus 4 into 1. You will get minus 2 and minus 2. Consider this trick as sometimes we confuse what will the rank of this matrix. So here A matrix they have given as 2 by 2 matrix and x0 is given as 2 by 1 matrix. 2 by 2 means what? 2 rows and 2 columns. Similarly 2 by 1 means what? 2 is the number of rows and 1 is the number of columns. So there is only one column but there are 2 rows. So we will not consider 2 into 2. So we will consider 2 into 1. So we will get answer as 2 into 1. Remember this because sometimes we get confused whether we will get matrix as 2 into 1 or 2 into 2. So AX0 will be minus 2 and 2. Take the highest number outside. So highest is 2. So will AX0, 2 will be the outside. So divide by 2. So it will be minus 1 and 1. So x0 will be for iteration number 1 as 2 in bracket minus 1 and 1. Consider this as x1. Let's go for iteration number 2. So ax1. Earlier we have considered ax0. Now we will consider ax1. So what is A they have given? 3 minus 5 minus 2 4. X1 will be what? That we have calculated in the earlier iteration. That is minus 1 and 1. So minus 1 and 1. Similarly again this is A matrix is 2 by 2, x1 matrix is 2 by 1. So we will get the matrix as 2 by 1. So 3 into minus 1 plus 5 into 1. So here sign is minus. So we will consider minus 5 into 1. Similarly minus 2 into minus 1 plus 4 into 1. So we will get as AX1 will be minus 8 and 6. So highest number we will get outside. Highest number between minus 8 and 6 will be 8. So we will take 8 at outside. So 8 will divide both. So minus 8 divided by 8 will be minus 1. 6 divided by 8 will be 0.75. That will be your x2. So iteration 2 that we have completed. Now we will go for iteration number 3. So ax2 we have considered ax1. We'll start with ax0. Then we have calculated ax1. This is x1. Now we go for ax2. So it is ax2. ax2 will be A is what? 3 minus 5 minus 2 4. x2 is that we have considered in the calculated in the earlier iteration. That is minus 1 and 0.75. That will be your x2. So minus 1 and 0.75. Similarly, we will multiply both the matrices. 3 into minus 1 plus minus 5 into 0.75. We will get minus 6.75. Similarly, minus 2 into minus 1 plus 4 into 0.75. You will get 5. Now between these two values, 6.75 is the highest one. So we will take it outside. So minus 6.75 divided by 6.75 will be minus 1. 5 divided by 6.75 will be 0.7407. Consider this as x3. Similarly, go for iteration number 4, ax3. You know the x3 value is minus 1 and 0.7407. And A they have given as 3 minus 5 minus 2 4. Again we will multiply both the matrices. Ultimately you will get 6.7 minus 6.7035 and 4.962. Highest value between the two values will be 6.7035. We'll take it outside. So we'll divide both the values by 6.75. So it will be minus 1, and 4.962 divided by 6.703 will get 0.7403. So that is nothing but your x4. Now, similarly, we calculate iteration number 5 and ultimately we will get minus 1 and 0.74031. So highest value eigenvalue is 6.7015 and corresponding eigenvector will be minus 1 and 0.74031. This is the method 1. Similarly, now we'll see how to calculate the eigenvalue and eigenvector by method 2. They are given A matrix as 3 minus 5 minus 2 4. So A minus lambda I. This is the formula you have to remember to calculate the eigenvalue. So A, that is 3 minus 5 2 4. Lambda will keep it as it is, and I. Here matrix A they have given as 2 by 2. So identity matrix will consider is also as 2 by 2. It is 1 0 0 1. So what we will get? 3 minus lambda minus 5 into 0 is minus 5, minus 2 minus 0 will be minus 2, 4 minus lambda is 4 minus lambda. So 3 minus lambda multiplied by 4 minus lambda minus 5 into minus 2 will get minus 12 minus 3 lambda minus 4 lambda plus lambda square minus 10. So ultimately if you calculate this, we will get lambda square minus 7 lambda plus 2 equal to 0. So factors for this will be, it is power is 2, so we will get 2 values. So lambda will be get 6.7015 and other one is 0.2984. These are the two eigenvalues. Highest eigenvalue between these two is 6.7015. Now let's calculate eigenvector for this value, that is lambda is 6.7015. The eigenvector M1 associated with lambda 2 is 6.7015 is obtained from the cofactors of the matrix. So lambda 2I minus A. Lambda 2, why lambda 2? Because highest value between the two is minus 6.7015. So same that we have calculate over here, 3 minus lambda minus 5 minus 2 4 minus lambda. Here lambda we have considered as lambda 2. Okay, this is considered as lambda 2. So put lambda is equal to 6.7015. So lambda 2 minus A will be in place of lambda, we will consider lambda 2 value as 6.7015. So 3 minus 6.7015, this is minus 5, this is minus 2, 4 minus lambda will be 4 minus 6.7015. So if we calculate 3 minus 6.7015 will be minus 3, minus sign should be there, 3.7015 minus 5 minus 2 and minus 2.7015. So let's calculate. You can consider first row or you can consider second row. I will calculate by second row. So C11 and C12 is equal to minus 1 raised to, I am considering second row. So second row first column for this element. So minus 1 raised to 2 plus 1. So we will not consider these values, that is 3.7015, and adjacent value will be minus 2.7015. So this will remaining is minus 5. Similarly, minus 1 raised to 2 plus 2. Why 2 plus 2? Because I am considering second row, second column. So 2 plus 2. So this will be what? We not consider above elements of 2.7015 as well as adjacent element of 2.7015. So remaining will be 3.7015. Minus 1 cube will be what? It will be minus sign. So minus 1 cube will be minus of minus 5 and minus 1 raised to 2 plus 2. So minus 1 raised to 4 will be minus sign. So minus become minus 1 cube will be positive. This will be minus 1. So minus of minus 5 will be plus 5. Minus 1 raised to 4. This will be sign is positive. So 3.7015 will be positive. So ultimately highest value between these two is 5. So we take 5 as outside. Remaining will be what? 5 divided by 5 is 1 and 3.7015 divided by 5 will be 0.7013. You can calculate the same by considering the first row. So M2 is the eigenvector for eigenvalue of lambda is 6.7015. So this answer and by method 2 and this answer by method 1 you will get same. If you check it, you will get the same. Similarly, if you want to calculate by first row, what we will do? Minus 1 raised to 1 plus 1, because first row, first column will not consider these two values. So into minus 5. Similarly, for minus 1 raised to first row, second column. So minus 1 raised to 1 plus 2. In bracket, we will not consider these values. We will consider minus 2 over here. Okay. If you calculate it, you will get the same answer. Thank you.